Okay, so there were some errors on the previous video, so I wanted to correct those really quick. If I have time, I'll go back and fix it. Otherwise, 5 minutes, I'll fix those errors. So in the previous one, we talked about rate of change, but it didn't, I don't know, there was some mathematical errors in there somewhere. So this formula is still going to be, this formula is still going to be h of 10 minus h of negative 2 all over 10 minus 2. 10 minus negative 2, so 10 plus 2. This is that f of b minus f of a all over b minus a. And so with this, in the previous video, I believe we kind of forgot to have this as a negative value. So h of 10 should have actually been positive 1, negative 6, and positive 2. So that would have been negative 3. And h of negative 2 was still negative 1 because we are going backwards. So this actually gives us values of negative 3 minus negative 1, so plus 1 over 10 plus 2. So that gives us negative 2 over 12, which gives us negative 1/6, which is the more appropriate and correct answer for this. Here's our answer. And so because of that, then this problem, used that information, so we needed that. I explained the first half of it, so it becomes negative 1/2 x plus 1 equals my negative 1/6. So now if I solve for x, I should get negative 1/2 x equals negative 7/6, and then that becomes x equals positive 7/3, which is the more appropriate correct answer. There we go. All right, so we talked about sketching this graph. So when we sketch this graph, we're sketching the graph of h given f. So what is that? Well, first of all, let's remember that our f is actually what we consider g prime when we look at that g prime, g double prime relationship. So then what's h? H is simply just g. So let's create a little chart to kind of get us going. Here would be the X-Intercept Intervals and important parts, right? From 0 to 2, and then something's happening. From 0 to 2, or so negative 2 to 0, and then 0 to 2, and then something's happening here. From 2 to 6, 6 to 8, 8 to 10. So let's address that. So from negative 2 to 0, so let's start with our increasing, decreasing. It's pretty easy. So this is above the x-axis, so it must be increasing. Above the x-axis, increasing. Below the x-axis, decrease, decrease, and finally increasing. What about concavity? Well, this is a positive slope, so it must be concave up. Negative slope, concave down. Negative slope, concave down. Positive slope, concave up. Positive slope, concave up. So there we go. The other thing we want to label is what are these weird, funky things happening? Well, at 2 and at 6, I'm hitting the 0 value. What do we call those? Those are our critical values. And then here and here, they're changing slopes, so we call those our points of inflection. Then we got to double check that they truly are points of inflection, critical values. So let's look at this critical value. I'm going from above to below. So yeah, that's going to be correct. Below to above, yeah, that's still a critical value. Point of inflection, I'm going from a positive slope to negative. Of course, we could also look right here. So from increasing to decreasing, yes. Where is this one? Decreasing to increasing, yes. Let's look at our points of inflection. Concave up to concave down, so yeah, that's got to be correct. Concave down to concave up, yep. Change of inflection, that's what point of inflections are, right? And specifically, we can actually label what these critical values are, right? At 2, I go from above the x-axis to below, so I went from above to below, so that must actually be a max. Over here, I went from below to above, so that must be a min. So then all we do to sketch that graph is we just do it part by part by part. So from 0 to 2, we said it was going to be concave up and increasing. So I look at my concave up. This is the side that's increasing. So from 0 to 2, I must have a shape that looks like this. Then there's a point of inflection here. Then from negative 2 to 0, I keep saying that. From 0 to 2, it's going to be concave down, but still increasing. So this side, do that wrong. We're going to be concave down and then here we have our relative max. So we're going to have max at 2. Some sort of max. We can label our other one at 6, some sort of min. From 2 to 6, we have it going concave down and it's decreasing. So concave down and decreasing means on this side it must go like this. From 6 to 8, it's going to be concave up, but it's decreasing, so like this on this side. And then the other side's the opposite. It's concave up, but increasing, so it's gonna go like that. And then you just kind of connect those in the appropriate manner. We'll do it a different color. So let's say we have a max over here, and we'll put our min right here. I don't actually know them, but so it's gonna go like this, and it's gonna change in direction. So it's gonna go like this and like that, and I have that point of inflection at 0. And then I'm gonna come across, I can't forget there's my other point of inflection. Ooh, I labeled my min at the wrong spot. That would be why. My minimum is actually gonna be at 8. Where's 8? 8. Here's my min. So we'll put it right here, minimum. This is a point of inflection, that's what this is. So I'm gonna come down, and then at my point of inflection, that's when it's gonna change. So I'm gonna go like this, here's my point of inflection, and I'm gonna continue up. So in red is our true curve, where we've got our points of inflections, actually changing our concavity, our maxes, and our mins. And that's today's correction lesson.